Hi, everybody. Welcome. I would like to welcome everybody to this day, and I will talk about how to see what's happening inside your OpenStack infrastructure, specifically using the Elastic Stack and Prometheus. So, a little bit about me. As my boss just told you, my name is Csaba Patyi, and I'm from ComponentSoft. I have 6 years of experience from the operations side. I started as the Oracle DB consultant, then Linux sysadmin administrator. Now I am an OpenStack consultant and instructor at ComponentSoft. I have a Mirantis certification. I am also a certified OpenStack administrator, and I also hold a Linux certification from the Linux Foundation. And the agenda is just one slide more about ComponentSoft, then one slide reminder what is actually OpenStack. Then we are going through the logging considerations and solutions for with Elastic Stack, monitoring with Prometheus, and just briefly touching the Monaska and Selioska, which are new OpenStack project. Each and every topic can fill out a full presentation. So in this presentation, I'm really just tipping the surface. And I just want to point out some directions if you are still ahead of introducing OpenStack into your own business. So what considerations you have to take in care. So about ComponentSoft, we are mostly education company. We are providing many different topic education services. Our main topics currently is OpenStack, Docker, Kubernetes, and Ceph. But we also providing Linux and other open source technologies. And the last, I think, 2.5 years, we are providing level 3 support to one of the major telco company private OpenStack infrastructure. So if you want to ask more, please visit us at www.componentsoft.eu or write us an email at the info@componentsoft.eu. And you can also send me an email to Csaba@componentsoft.eu as well. So what is OpenStack? OpenStack is basically, for the marketing terminology and or the end user perspective, is just a cloud operating system, an operating system, a special abstraction layer which is hiding the fact what type of hardware resources you have. The end user only want to launch a virtual machine, and he doesn't really care about it or shouldn't really care about if you are using Xen, KVM, Hyper-V, or any other technologies, or what network devices you actually having in your data center. OpenStack is just a special abstraction layer acting like as a cloud operating system for the end user perspective. But in reality, OpenStack is actually a combination of different projects, and well, each and every project is responsible to managing one special area about the life cycle of your data center or your resources. So each and every project is responsible to allocating your resources and providing those resources to your end customer, which can be external or internal ex-customers. And each of these projects working together to provide the services for your end customers. So the next question is how you can distribute those projects. So each and every project has a few components usually, and it's up to you to decide where you want to decide. This diagram shows one specific or one possible combination how you can distribute these services. You might notice that we are not just talking about OpenStack specific projects like Horizon, Cinder, Glance, but you also have to take in consideration of deploying and managing other open source or proprietary softwares, which is basically supporting your OpenStack function and functionality, which is namely the one type of SQL database, usually MySQL, or a message queue service, which is RabbitMQ. And each and every of these projects is basically just providing you the service what you want to use. And usually what you want to use in OpenStack before the big container hype was just to start virtual machines. And when you are starting virtual machines, as you can see, there are many, many steps involved, starting with authenticating the user, making sure the user has proper rights in order to be able to reach special images, be able to deploy the virtual machine in special networks, allocating storage resources and stuff like that. So there are many, many steps, and the devil never sleeps. So each and every step, something can go wrong. So okay, you hit an error, no problem. Let's just check the logs. Where the hell are the logs? So if you want to find out where are the logs, you can go to this website. It's a little bit small, sorry about that. Basically, docs.openstack.org, the OpenStack release name, and /config reference. And you can read about all the locations of the specific log files for each and every project. Or you just run this specific bash script for each and every your node, and it will be calculating based on the name of the logs that which project has how many log files on that specific node. And if you did this, just I did, you come up with the numbers like shown in this diagram. So let's say you have 3 controller nodes, 2 network nodes, 20 compute nodes, and 6 Swift storage nodes. So you're ending up 31 physical node and more than 300 log files. So if you hit an error, good luck. You have to be the greatest detective on the earth to manually check all those logs and find the proper solution that, okay, what just happened here? Okay. So, Elasticstack. In the last few years, Elasticstack is really became the de facto standard for centralized log management. Formerly, it was known as ELK-Stack because of the 3 main components: Elasticsearch, which is storing and indexing your logs, your information, and makes possible for you to be able to do real fast searches against your logs. Logstash is transforming the incoming logs and based on special filters. It will try to make some extra structure inside your raw log data, basically. So Logstash is helping transforming your logs and give some structure to your raw logs information. And Kibana is the web user interface. So these 3 components was the original ELK-Stack. But the Elastic company, so the company behind the ELK-Stack, tried to rename its brand, saying they are now not ELK-Stack but Elasticstack, because they developed some extra modules and plugins, which is wider the possibilities of the Elasticstack. One of them called XPack. XPack is providing extra monitoring, alerting, and security capabilities for your default Elasticstack. Most of those extra packages are you have to pay for that to be able to use, and there are a few other freely available plugins, which is so-called beats. There are many, at least 6 or 7 type of beats. The one which is interesting for us is the file beat, which is basically just a really small agent. It's only consume maybe 10 megabyte of RAM on your physical machine. So you are installing this file beat on your physical machine. It's just collecting your logs and just sending your Elasticstack, basically. So how can you use the Elasticstack? The very simplest configuration, you need Elasticsearch, the FileBeat, and Kibana. So you don't even need Logstash, because FileBeat now in the latest Elasticstack, starting with version 5, can send logs directly to the Elasticsearch. And what I really like about FileBeat is, at least for me, it's much more readable than the standard rsyslog Linux version of standardized log management and log forwarding. So you're just specifying that all the paths, log paths, what you want to collect. You can even use regex, like the last one, /var/log. Can you see? No, you cannot see my mouse. Sorry. And you just say, okay, I'm specifying the output. The output is the Elasticsearch, and I'm specifying the Elasticsearch host name or IP address plus the port where the Elasticsearch is listening on. And that's all. So what is the benefits? It's really easy. I think the syntax is really clear. You don't need to worry about logstash. The flip side is that when you want to search using the Kibana, 5-bit might be, and Elasticsearch might not be able to really make some structure in your raw data. So you won't be able to use proper search queries to filter out the information what you're actually needing. So, and one of the biggest issues in the OpenStack world is there are sometimes OpenStack producing multi-line logs. More on that a little bit later, but this method doesn't capable to handling the multi-line logs. So let's move to a slightly more complex config when you already start using the logstash from the Elasticstack. Logstash configuration, basically 3 parts: the input, the filter, and the output. In the input section, you're just specifying what type of mechanism do you want to use for accepting the logs. Now we are specifying that I am using beats, 5-bit, and I want to listen on port 5044. The output is the last section where I am specifying that, okay, after I am going through some log transforming, I want to send those transferred logs into the Elasticsearch. And the middle part is the so-called filter, and I'm using a special filter called the grok filter. That's probably the most advanced filter in Logstash. Basically, from the raw data, I'm just extracting the information like the timestamp when that log was actually came to existence. I'm trying to extract the log level information and what module produced that log, and the rest of the message, basically. And now I have to specify with more complex, or I can specify with more complex 5-bit configuration as well. Without Logstash, I am still able to use this document type and tags. The most important part is that I have to change the output from Elasticsearch. So the previous Elasticsearch, the output, is changed to Logstash. And again, I'm specifying the Logstash server IP address or hostname and the port where Logstash is listening. This will providing a better filtering options using Logstash, because I can use many special filter capabilities of Logstash to extracting raw data and make some structure of my logs. But the flip side, I need Logstash. So again, some extra software what I need to install, I need to monitor, I need to take consideration of HA deployment and stuff like that, and yet we are still not talking about the multi-line logs. So what about the multi-line logs? Sometimes certain OpenStack projects can produce this type of logs. So these logs, as shown in the picture, this log specifically is in 7 lines, but it's belonging to one single event. So if I am not configuring properly my 5-bit or my Logstash, then basically at the end of the Kibana, all these lines will be handled as different events. I don't know why the OpenStack developers producing sometimes these type of logs. It is really easy when you only have one log file and just looking at that, because it's really shown a table-like format. But again, when you have 300 different source log files and you want to search what actually happened here, you want to really dealing with this type of log message as one single event. So you can choose, do you want to handle this multi-line event processing on the 5-bit size, or do you want to deal with it on the Logstash size? So let's check that what are these. If you want to handle it on the Logstash size, you have 2 options. One is already deprecated, that's the lower part. There is a special filter, or there was a special filter called multiline. But the new method, the new preferred way now, it's called use this type of so-called codecs. So basically, you just specifying that I want to use a codec for my input method. I specifying the pattern. The pattern here is that every log event is starting with this timestamp. If this is not true, so I'm seeing a line which is not starting with a timestamp, then please add it to the previous line and handle it as a single event. What is the benefits using Logstash and having this type of configuration? That you are able to recognize these multi-line logs and handle it as a single event. The problem with this is that Logstash is working with, Logstash is basically a Java application, so it has its own buffer. And if you have many log input log sources and you are coming with many multi-line logs, the buffer might start getting full, waiting the end of the event. If you have many multi-line events and you didn't give Logstash enough memory, you might ending up, a full buffer, and Logstash and log mechanism is just stops working on it. But also one extra or positive side is that you can use the special grok patterns. In this URL, I will share the slides later. There are many different complex grok patterns for be able to detect special projects, binaries which are producing logs, able to detect a special timestamp format and things so on. So that's the plus side. What about Firebit? If you are choose to you do this the same way on the Firebit, this is how you have to do. You add this multi-line pattern configuration, and now you are removing the load from the Logstash because you are actually calculating these events on the edges or on your physical machines, and you are just sending the logs or all the logs as one event to the Logstash. What's the problem with that? The main problem with this solution is that it's you are limited to use only a single Linux regex possibilities. So you cannot really use complex grok filters to be able to match your patterns. So how this is visible? Okay. So this is how it's looked like from the Kibana. Kibana is, as I mentioned before, is the Elastic Stack web interface. And this is basically you see here the raw log messages. And you can create special queries. Based on those special queries, you can create so-called visualizations. Like, for example, in the previous slides, I show you that. What? Okay. I show you that I trying to extracting, for example, the log levels. So based on log levels, I can create nice charts. And with charts and stuff like that, I can create dashboards for managing my logs, and where I can put charts and I put pre-saved queries. And as you can see, for example, here are all my logs files. And even with this, let me try to make a little bigger, sorry. So as you can see, Logstash was able to pick a bunch of metadata from the raw logs, like what is the host name where the logs is originated, what is the log level. I was able to add special tags like OpenStack service log, Nova, beats input, and there is the actual log message. And with the help of this information, I might be able to filter logs, like I say, okay, I'm only interested in, for example, warning messages. So I just okay. That's because probably in the last 15 minutes there was no error, which is really good. Let's check the last 7 days. Hello. Type is maybe it's internet connectivity. Hello. Okay, so this is the demo gods, but don't worry. I'm cheating. Okay. This video was recorded yesterday, so yeah, here I'm. Oops. So where is the? I just try to. Okay. So yes, log level. Okay. I just realized what I made a mistake. Okay. And if it's not working, oh, yeah, okay. So yeah, it was not the type, it was the log level what I wanted to filter. Sorry about that. So yeah, so basically you have this really amazing query filter options for working with your logs in OpenStack. So that's concluding our Elasticstack part. Is there any questions regarding to Elasticstack so far? If not, I am going to move on with the Prometheus monitoring. So is there anything? Yes? What is the resource usage of? How does it scale? So the good thing about Elasticstack is that you can, it is three main components, the Elasticsearch, the Logstash, and the Kibana. And Elasticsearch can be deployed in the highly available clustered way. Logstash can be deployed as well. Kibana, I don't think so, but it's really well scalable solution. So you can have a bunch of Elasticsearch servers working together, a bunch of Logstash servers working together. So it's really easy to scale, and the documentation of the Elastic stack is really good. So it's really good. The resource usage is not really relevant in this example because I have 4 machines. And I think I gave 1 gigabyte for Elasticsearch RAM and maybe 500 megabyte of the Logstash. The thing is, it is a Java application, so if you have 100 machines, it's not not a linear stuff, but just to start the application, you need some memory and stuff like that because Elasticsearch and Logstash is written in Java. But it's a really scalable solution, and most of if you are not using the XSpec module, which is a payable version, you can use the free version of Elasticsearch to be able to scale for really large clusters of Elasticsearch and make the functionality really fast.
Collecting on one node, all the nodes logs doesn't make any problem.
No. So you are deploying Elasticsearch. So you are deploying Elasticsearch on different machines, different physical machines, basically. So you have a main Elasticsearch server, and you have a few other Elasticsearch servers as workers or slave nodes, basically. And Elasticsearch is working in the way that when you are introducing a new raw data, or an already a little bit modified data from Logstash, it is giving a special index for each and every document. Basically, it's working as a document database. So, and making sure those indexes are, it's called sharding, shard across your Elasticsearch cluster, basically. Yes? Let's check. Yeah, it's case sensitive. Yeah. Yeah. Okay. Yes. I'm not sure if I'm not using the parentheses, what's gonna happen. Oops. Yeah. Yeah. It's okay. Let's move on. So, so far we talked about logging. but you want to do some monitoring and alerting as well. So what are your options? You have your traditional options like Nagios, Zabbix, Xenos, which are coming from the open source world, and we heard about the city network people that they are using, for example, OP5, which is a fully commercial monitoring. The problem with, at least with the traditional open source solution, is that they were created and written in the time when an operator have to manage dozens of servers maximum. So and all the extra options that, okay, let's make Nagios be able to monitor your cloud was added as an extra. So it was an extra hackering and tinkering the Nagios side to be able to properly work in the cloud environment. And there are some new players. One is the OpenStack itself, with the help of those extra modules like the XPack alerting and monitoring. The problem with that is has a commercial license. You have to actually pay for that. And the other new player is called Prometheus, and I want to talk about that in the next few slides. But that's, so far we are covering the infrastructure of your physical infrastructure. And what about the actual virtual infrastructure inside your OpenStack? So how do you want to, or how can you monitor the virtual machines and the state of those virtual machines? Traditionally, I would say the solution was Celiometer. I will talk about a little bit more later, and briefly I want to talk about with Monaska and Celioska. So let's talk about Prometheus. So it's an open source system monitoring. It was created by the SoundCloud startup company, and it was created in the way that it's from the beginning, it was written to a cloud environment. So the Cloud Native Computing Foundation picked the Prometheus as its second project. So the Cloud Native Foundation promoting many different cloud native solutions like Kubernetes, Prometheus, dtrace, and many more. So Prometheus was the second on that list. Some of the features of Prometheus, which is, I think it's really important, is that Prometheus is basically a time series database. And the way how it is working, it's not working like you are, or the main feature, what I think is really beneficial from a cloud in a cloud environment, it is capable to automatically detect target hosts, what you want to actually monitoring. And how it does is, so far, it can use built-in functions from the Swarm cluster or Kubernetes, or even it is capable to connecting to your name server, and based on the name server information, the IP addresses and name informations, Prometheus is capable to automatically detecting new resources, new virtual machines that you want to monitor with it, or you can manually add targets to the monitoring capabilities. And one extra feature is, or the mechanism how it's working is that it is a pooling mechanism. So you will have to deploy a special agents called exporters, and the Prometheus server will connecting those agents and pooling the special metrics from the target machines. Some of the components of the Prometheus, let's say, ecosystem is the main Prometheus server itself, the special purpose exporters, which are basically just agents providing the information for Prometheus. There is an alert manager, so the alert management, the alert capabilities is divided to the special module, which is independent from Prometheus. This is beneficial because you can have multiple Prometheus server which can detect or monitoring the same systems, and multiple alerting management, alert manager services. So if there is something goes down, you still have a full monitoring, because Prometheus was designed in the proper way that it is not hard to, install Prometheus in an HA way, because all the alerting capabilities are be able to deployed in HA independently from the actual monitoring agents or the monitoring part. This is the Prometheus architecture. The main information here is that we have the Prometheus server, we have the job exporters, we can have a web user interface, and we have an alert manager. And the really cool stuff about that is you can deploy many Prometheus servers which can monitor the same agents. And if one Prometheus server goes down, no issue, you have another secondary or third Prometheus server. and they can send the information to the alert manager if it is detecting there is a problem. If one of the alert managers goes down, no issue, because you have many more alert managers, so you are still good to go. And also the alert managers capable to communicating with each other. So if one Prometheus server sending the alert information to 3 different alert managers, the alert managers communicating each other, and only one will send you to the actual alert. So you are not ending up, 100 emails or 100 SMS that, hey, one server is down, please do something about it. This is my deployment. Basically, I have an OpenStack deployed using the pack stack with 1 controller, 1 network, and 2 compute node. I have a Swarm cluster, and inside the Swarm cluster in Docker containers, I installed Prometheus, the Grafana, which is a web user interface, an alert manager, and my Elastic stack, basically. And also for each and every physical machines, I deployed the special exporters. What do you have these exporters? These exporters basically collect informations from your physical machines and providing that information. And you have many, many specialized exporters which can be used for, actually monitoring OpenStack or OpenStack related projects or softwares, like the MongoDB, the MySQL server, the RabbitMQ, the Ceph, the Gluster. So you have many, many exporters which can collect informations for you. And there are many, many more. So currently, I think a Prometheus ecosystem has at least 100 or a little bit more exporters. What Prometheus itself knows, I mean the Prometheus community. Many, many exporters are not, registered in the Prometheus ecosystem, but you can go to GitHub and start searching about Prometheus exporters. The thing is, there is no OpenStack exporter in this list because there is no official OpenStack project-related exporter. So what you can do so far with Prometheus is that you can monitor a bunch of OpenStack-related software like the MySQL and the RabbitMQ. But another beneficial part of using Prometheus is that Prometheus was developed for the container ecosystem. So it already has built-in Swarm monitoring and Kubernetes monitoring exporters. And just right now in the next room, they are talking about how you can deploy OpenStack using Cola, which is basically deploying OpenStack inside containers on Swarm or Kubernetes cluster. So if you are able to monitor your Kubernetes cluster with Prometheus, which is monitoring your Docker containers, you are basically good to go because you are monitoring your OpenStack with Prometheus. Because that's the future, that OpenStack try to move, that you are deploying your OpenStack inside the container way. It's just a headache for the operator, and it's just a headache for the learning curve, how you can use OpenStack. First learn Docker, then learn Kubernetes, then learn OpenStack, and now you're good to go. But it will be really beneficial when in terms of the upgrading of OpenStack from one version to another. This is a Prometheus configuration file. Basically, what is really interesting is that you just say that this is the job name, or what I want to use to find ports 9100, where basically the node exporter will be exporting those metrics what I am interested in. And I want to use the DNS, basically. So every 30 seconds, run a query against my DNS, search for A records, and what you are find their IP addresses, go to those IP address 9100 port, and pull those query metrics what you are able to find. So this is the dynamic configuration, but you also can add hosts manually as well, if you wish. Some Prometheus query examples. So it will make more sense when you will see the actual metrics. So you will see a bunch of metrics which is provided by those exporters, and you can use these metrics in order to calculate informations like CPU usage, or you can also predict that maybe the disk will fill in 4 hours. It is really, really well documented. So Prometheus, one of those rare open source projects which is really well documented at this point as well. So please check out later. This is the alarm syntax. I think it will be easier if I actually show it in the demo. Okay. So these are basically the metrics which is provided by one of the Prometheus exporters. For example, if I'm searching CPU, you will see that idle information and stuff like that. And these exporters are really, really small agents, lightning fast. They are calculating these metrics over and over again. And I am just basically using these. I am refreshing this site, basically. And the Prometheus server is basically just sending a pull method against these, basically, let's say, web page and collecting all these metrics. This is how the Prometheus itself looks like. Let me make a little bit bigger. Oops. Okay. So these are all the targets, which is fine by my Prometheus. I see I have a few down. At least I can show the alerting system. So these are all few of them was discovered manually because I added these, for example, these few, I added these manually. Few of them was discovered from the DNS for the Swarm DNS server, Swarm, let's say, built-in DNS server. I can check the configuration as well, which is basically almost the same what I just showed you. And basically, if I go to this Prometheus main site, I can see all the metrics collected, by Prometheus. Okay, come on. So all the metrics collected by Prometheus, and I can use the previously showed complex patterns in order to calculate different values, and based on those values, I can send alerts. Yes?
What is the security? Because here I see that you can access...
Directly, yes. I didn't read that many, but the Grafana, so in Prometheus, you can disable this part of the Prometheus completely. So this is just for the demo purposes. What you actually want to use is, for example, the Grafana dashboard, which I just want to show next. So based on those metrics and calculations, you can define really nice dashboards that, okay, what's happening inside your OpenStack environment. So how many nodes, how many the overall deployment and stuff. And Grafana itself, it will requires authentication from you. The rest of the stuff of what I just showed you previously, this Prometheus, you just deny it from the firewall, this 3000 port. You just don't let anybody to reach the Prometheus server directly.
This is a call-like collection.
Yeah.
That means the server has to access all the other servers.
Yes, so you have to open the firewall for all your Prometheus instances from those ports where the node exporters actually providing that info.
It's true for your administration laptop as well, because you have got direct links to the monitored servers, not to the Prometheus.
Yes, right now, yes. So this is only a really, really small test environment just for the demo. This is what we are using for teaching people for the certified OpenStack exam. So I didn't put any security measurement, otherwise I just blew my mind. So it's only for demo. Don't use this at home. Okay. So yeah, I think this covers all about Prometheus. Let's go. So what is missing? Prometheus still doesn't have a proper metrics just specific for OpenStack, which is really official. It's not 100% true because the canonical team behind the Ubuntu Linux distribution, they already started developing their own Prometheus metric extractor system, and it's completely free and you can use it and download it from GitHub. It's still early stages, so you can start using it, but it's not too much data what you can get out of it. And the biggest issue about both Elasticstack and this Prometheus stuff is that you cannot provide this as monitoring or logging as a service for your end user. So you cannot provide these methods for your end user if you are providing a public cloud. This is all your internal infrastructure. And the question is, okay, but what is Celiometer for then? So about Celiometer, it was divided into three separate projects. Celiometer for the metering, this Ouch for alarming, and Notchi for time series database for long-term data storing. And it was only a telemetry service. So it was originally planned that it will be collecting information, and based on that information you can send some bill at the end of the month for your clients. It was never really designed to be a proper monitoring tool, and it doesn't have any dashboard support by default from the vanilla OpenStack. Plus it doesn't really give you proper way to configure complex conditions. The only way how you can create alarms for Celiometer is using the command line, which is really ugly. You can check on these later, but it's really, really ugly. And the main Celiometer main problems is that because it wasn't designed in the way that it should be a proper monitoring, you should only check, your status about how much virtual memory I am allocating every 15 minutes in order to, send a bill about 1 hour memory usage. It collects too many data, and it's just introducing a massive problem for you that you have to store that data what Celiometer actually collects. And the other problem, if you are increasing the sampling time, so you are sampling more often, you are actually putting a load, a stress, an extra stress against your message queue server. So basically with your monitoring, you can bring down your own OpenStack infrastructure, which is just a crazy way to do this. So that's URL, the short URL. You can go to a Google spreadsheet where you actually calculate for your own numbers, that number of virtual machines, number of RAMs and stuff like that, and that Google spreadsheet will calculating the amount of gigabyte what you end up consuming per month. So in order to solve that problem, there is a new project called Monaska and Celioska. Monaska is basically a monitoring as a service. It's supporting complex metric collection and complex alarming capabilities. It tries to solve all the previous problems, and the nice stuff is that it is an OpenStack project, so you can authenticating against Monaska using Keystone. So it's really a built-in feature, or should be, or will be a built-in feature. And behind the scenes, it can be used Elasticstack for logging, and there is a blueprint for using the Prometheus metrics behind the scenes as well. So I think this is something what you really should check out. And to be able, you can already participate, help the deployments or the developers. There will be a link what you can use here. I will share the slides soon. Where there is a survey from the Monaska developers that what you want to expect from a monitoring as a service solutions. The biggest problem right now with Monaska is really, really complex, and it's really, really badly documented. So this is the Monaska architecture, and I must give credit to Tamás Gércei, who was volunteered as a tribute. He is one of our former students who was went through hell to be able to deploy Monaska, and as you can see, Monaska itself is using many, many different agents and software parts to work properly. For example, the Monaska API is written not in Python, but in Java. I don't know why. There is a Monaska agents, and even the Monaska agents containing 3 different software. It is using Kafka instead of RabbitMQ for storing the data. It has its own compute engine and its own configuration server and whatsoever. So it's a really, really complex stuff. And we had the experience that we deployed it, we had it run for a few days, we had to go do something else, and when we came back, it just crashed. And we just, what happened? And the funny thing in the logs that we see that, okay, after 3 days it crashed, then it works again magically for 1 day, and it's crashed again. I don't know why. I have a video about when it's working, so let me show that.
Actually, Tia is here.
Yeah,
The main OpenStack engineer. So he may have some comments.
Yeah, so yeah, so Tamás is here. So if you want to get questions for hands-on experience about Monaska itself, then please ask the questions to him because he went through all the trouble to being able. So after you install Monaska, you will have a dashboard, a monitoring part, and here in the monitoring section, you are actually can create new alarms based on special metrics collected by the Monaska agents. So you can specify, let me a little bit speed up. No, this way. The alarm name, you can specify the severity of that alarm. Then you can specify the function. The function can be minimum, maximum, average, count, stuff like that. You have to specify the actual metrics, what you want to calculate the certain event. So it has a really nice built-in feature, built-in dashboard feature, and you can, provide this monitoring capability to your end users, to your OpenStack end users. And one extra stuff what is Cellumeter doesn't provide you, if you can do complex alerting. So you don't have to watch only one metric. You can combine as many metrics as you want. And based on that complex metrics, you can get an alarm, basically. That's all from my end. Does anybody has a question about Prometheus, about Monaska? Monaska is for Tamás in the break. I'm here for the Prometheus questions. Okay. Yeah. Let me stop there. These are all the resources, and I will share the slides soon. I think there will be a proper part of the web page of this event where I can share this slide. These are all the resources what I used during creating this presentation, and thank you for your time in it.